Hey, what's up everyone? Welcome to the stream. So one change I made, and hopefully it's okay there, but I increased the pickup on my mic. So I noticed that my recent videos were kind of low on volume. So right now I put it up. I see that it kind of enters the red. I hope that this doesn't cause any kind of, like clipping. But I did a test earlier and I listened to it and it seemed good. So I'm going to go with that for now. If you guys have any feedback on the audio, just let me know. Okay. So, so last week I wasn't here. It was a spring break here in Canada. So I spent time with my family. So the last time I streamed was about a couple weeks ago on Thursday, I think. And we had hit a kind of milestone in getting the DAP thing to work. So basically, if I go and I run the Vectrex debugger extension in VS Code with my Vectrex Pong game here, and I hit F5 or debug, it launches Vectrexy. It parses RST files, which currently takes way too long, and it stops here at main, which is pretty great. That was the milestone that we hit last time. Like right now, nothing else works. If I do like step over, it'll basically just block because it's sending out the commands and it's waiting for the server to respond. It's probably going to time out at some point. So yeah, that's going to be the next step, is to be able to do stepping. So I'm just going to stop this here. Now, to get this to work, I kind of made a bit of a mess. I'm going to go through and try to clean this up so that we could keep working. I actually started a little bit of cleanup after the last stream, but I'm just going to go over it again and remind myself where I was at. Oh yes, init console. So there's a DAP debugger. Yeah, I did this thing where I decided to replace argc and car star argv with a vector of string views. Debug symbols. Yep. Okay, so the implementation of the debugger. Okay, that looks fine. Yeah, so this is where instead of iterating through and checking stuff, now I can just do if contains args server, if contains args client, because it's a vector and I have a little helper called contains up here, where it's basically just a little helper to do a find not equal to end. So that just makes this a little bit easier. I do the same thing in, where is it? STL engine. Yeah, so here's where I construct my vector of string views. And then over here, I check, I look for -DAP. So if we launch Vectrexy with this, right off the top, I have to do this crap here of like, change on Windows, changing stood in and stood out for text mode to binary mode, so that it ensures sequences of Linux-based new lines are not changed into Windows-based. And also, I make sure that my output and error streams go to a file so that any kind of printing that I do doesn't get in the way of the protocol. Now, this is, in my mind, temporary because I'm pretty sure that we can implement DAP on a socket rather than using stood in, stood out, but it's something I'll take care of later. Okay, yeah, and then I pass that here. Okay, good. Oh yes, I wanted to get rid of this. So right now I have this. Oh yes, I also made some code where I modified my the engine client here. It used to have a debugger and a DAP debugger. So now I made those unique pointers and I initialize only one or the other. If you passed in DAP, then I create a DAP debugger. Otherwise, I create just a regular debugger, which I will eventually rename to like CLI debugger. But for now, I'm just leaving it like this. And then with that, I now have like code like if I have the debugger, initialize it this way. If I have a DAP debugger, initialize it this way. Eventually what I'm going to do, and I have this to do here, is probably make a base class called iDebugger with some virtual functions. And the idea is that there's only one debugger that can be live, active. So I'll create the one debugger, and then this code with multiple ifs and all that will change because this is kind of not very elegant. So yeah, I'll do that later. There's no need to do it now. Okay, so I think this is probably good enough to start staging stuff for this next commit here. It's fine. This is good. This is good. That's good. That's fine. Oh yes. So here I removed the printing. I wasn't sure what I wanted to do with this, but I definitely want to be calling find and set root path right off the top. So like in my STL engine, whoops, in my, try that again, STL engine.cpp. Yeah, so that's it. The first thing I need to do is set the root path, because after that, when I create this file here, I want it to be created at least relative to the root path. But this function was doing printing, and I can't have it do prints because of the fact that if I do that, it'll get in the way of the stood in, stood out stuff, and so that's not good. So it's sort of a chicken and eggs problem, I suppose. Yeah. So I think for now I'm going to leave these in comments, because if I do eventually do the like sockets version of DAP, I can bring these back. I think that's the best I can do. Right? The only thing I don't like is I don't know that that's the error. Maybe I'll just put, yeah, this is what I'll do as a mitigation. I'll just put an extra. Like if it fails, I could definitely print. You know what I mean? In fact, I'll error. What was I doing before? Failed. I'll just say failed to find and set root path. Okay, we'll do that. This way, at least if it doesn't work, we'll see something. Okay, so we keep all of this. Okay, this stuff I'll leave out. Okay, so there you go, lots and lots of changes. So let's say here, implement DAP, or I'll say make it stop at main. There we go. These changes make it so that when Vectrexy dash DAP is launched, it runs the DAP debugger and DAP debugger. So these changes make it so that when Vectrexy DAP is launched, it runs a DAP debugger and makes it so that the client stops at. Sorry, wait, hold on. Starts the DAP debugger, parses RST files or whatever, and stops at main in the program that is launched. All right, good enough. So let's commit that. All right, so what can we do next? Just give me a second. Okay. So one of the things I wanted to do was look at the thing that Jono last time recommended, which was rather than have this infinite while loop that I have somewhere here in main, that I actually implement the break at main, the break if attached, which we have here somewhere. Is debugger present? That's it. If it's present, break. So yeah, it was something like I want to put like a wait for debugger attached type of thing. And it would be sort of like platform wait for debugger attach. Why is it doing this? Just a mistake. Platform. Okay. Lock until debugger attaches to process. So far I only have 2 platforms to implement it for, which is Windows and Linux. For Linux, I'm just going to leave it empty, and we'll eventually implement it if it's useful. For Windows, That's kind of cute. If holding F1, maybe that's something I could do. We'll see. I'll do that more maybe on the outside. We'll see. Okay, so I guess that's fine. Sleep for 100 milliseconds, and then finally debug break. Excuse me. Okay, so let's see how this works. If I launch here, see right now it should be blocked. Let's make sure. Okay, that looks good. Then I come in here and I attach to Vectrexy. Oh, and there you go. It says triggered a breakpoint because debug break does that. I suppose I don't need to make it break though. That could be an option. And just hit F5. And now it's parsing the RST. And we continue. Perfect. I'll say break on attach. You know what? I'll just do it a bool. Oh, right. Can't link because Vectrexy is still running. There we go. So let's try that again. So this time it shouldn't break anymore. So I hit F5 here. It launches Vectrexy. Just wait a little bit. What would be really nice is if I actually show a dialog or something that says, you know, waiting for debugger to attach or something like that. Now we attach and we should hit a breakpoint at some point. Parsing RST, and there we go. Okay, so that works. That's great. Let's kill this. Relatively happy with that. Oh, actually, I don't want to check this in on stage. Okay. both for debugging. Whatever. All right, now we got that there. So let's get back to implementing stuff for here. So I was thinking about it, and if I go to my debugger symbols, debug symbols here, I think I don't have what I need, because now what I have is a mapping of symbols. What do I have here? Right, for symbol names. Yeah, right, I only have main, but I will eventually add other symbols. No, this is what I was thinking about, was how I have a mapping from every address to a source location, right? So it's like, but what I actually also need is the opposite. I need to know, given a source location, what's going to be the address. Because in order to do stepping, we're going to hit F10, right? Or whatever, F11, F10. And then the debugger is going to send me information that says, hey, a step was requested, and this is where we are right now. What do you want to do? I think. Or at least, yeah, I'm not sure. Let me see. Oh yeah, okay. So next, to do single line step, step in, step out. So I think I'm going to focus on step in, because that should be the easier one to do. And I need to look at what the StepIn request looks like. The request starts a debuggy to step into a function method if possible. If it cannot step into a target, StepIn behaves like next. The debug adapter first sends the response and then a stopped event with reason step after the step is completed. So that's us, the debug adapter. So we send a response, and then we have to send a stopped to say, hey, we've stopped on the next thing. So that's fine, because we'll do that with our temporary breakpoint mechanism. After the step has completed. So actually, how will I know? I think what it, okay, I think I know. Actually, I won't be able to do this with a breakpoint because I won't know what the next thing will be. I have to execute instructions until I hit one that has a source location. That's what I have to do. Because basically, the way to think about this is if we go here to main.rst. So we start here at main, right? So we actually start on this, this address A0AD2. We actually start on the one here that has the instruction. And basically I have an entry for each one of these stab D lines. So you see how stab D here, the very first instruction, that's stab D. What did I do? Did I put a source? I think I put a source location for all those instructions. Yes, I did. Right. Let me go see. So parse line, yeah, okay. So what I've got is, let's say in this case I have 1, 2, these two both have the same source location. So what I need to do is I need to step until the source location changes. Yeah. So let's say we're here. I have a current source location. We step this instruction. It's the same source location. Then we step again. We land here. This is a different source location, right? At that point, I need to break, to do a stop, and basically we break there. Now that's step into. Step over is similar. I basically have to simulate doing step over like I do in my other debugger. So when it's a call, we run all the code of the call. And unless there's a breakpoint, we just keep doing that. Yeah. Yeah, I think that makes sense. So actually then to that end, I have to rework my debug symbols, because right now I know that I'm copying symbols everywhere, and I shouldn't do that. Yeah. Well, I guess I could compare this way, but it's not super fast to do it that way. Plus I'm returning pointers here, which is kind of crap. Just thinking. Trying to think how I want to store all this stuff, because ideally what I do is, if we add the same source location, I don't need to duplicate it in memory, which is what I'm doing now. On the other hand, if I want to have unique versions, that means as I add, I need to see if they are already present, which means I need to have a way to hash them. So I could store them in an unordered set or something like that. I suppose I could deal with that later. Yeah. Doesn't have to be solved right now. One thing I think I will change though, I don't want to make this a pointer because it gives the impression that you could compare them directly. Although maybe eventually that's what I want. Okay, I'll leave this alone for now. So I'll get back to what I was saying. What we need to do is get the StepIn here. Okay, actually I don't care about these parameters. I just need to send it the response, which is here. Yeah, sorry, I'm just thinking about this code here. So this is not really clean. What I've done is I have this these atomics, and I'm sort of relying on the fact that when this gets called, my debugger is not running. It's not super clean. I think what I want to do is, at the very least, call functions on my debugger and then deal with maybe handling those things. I don't know. What do I want to do here? Stack trace request. Yeah, because you see the thing is that these handlers want to send a response right away. So because at first what I was thinking is, if I get this request, could I have a queue of requests and then my debugger could handle them on a separate thread? But then when I need to do a response, it's already too late because this function will be over. What I'm trying to think is it okay for me to do this code here? Maybe. Decisions. Okay, I think I'll leave it like this for now, and I'll see how far I can go. Because see, already I'm going to have a problem. If I need to step, oh no, that's it. I say, okay, I need to step, and then I need to break, and then send. Oh yeah, that's what it said, right? I have to send a separate event. If it cannot StepIn behaves like next. The debug adapter first sends a response, and then that's it, the stopped event with the reason stepped. Okay, that's what I need to do. So I need to say that a step into has been requested. So what I'm going to need is some kind of like state machine going here. So let's do this. Actually, I think we'll start in run. Okay, execute frame instructions. All right, see, I had paused here. I think I will not do paused. So if we're running, then do execute frame instruction. If we are stop in state stop, I don't know if I should say running and stopped and all that, I don't know. For now I'm going to put the active verb. If we're at stop, I don't know, we'll say nothing for now. And so stop is like paused. And if we are in the state StepIn 2, basically what we want to do now is we want to execute frame instructions until actually, it's not execute frame instructions, is it? Oh, it's on a per instruction basis. Right. Not sure. Let's see how this goes. I might need like a sub state machine or something. Yeah. Okay, maybe this will be more like the run state. And we'll have step into, step over, and I don't know what else. Step out. Something like that. Now for now, and in that case we'll keep paused as we had it. And I'll just have a if we're just running normally, step always, I guess. Or we're not stepping, so it could just be, how do I call that? Because this is basically step into the current instruction. If it's a function call, we step into it. Otherwise, we just step, it's just doing like a step over the current statement, if you will. Not really instruction, it's more like a statement. step over the current line of code. Otherwise, we are just running. Yeah, I don't know what to call it. Let's call it step always, for lack of a better name. All right, so here, what we want to do, we would like to know and make a function to get to PC, because I think I'm going to be doing this a lot. What's wrong? Oh. No, it doesn't like that. Actually, I don't really need this out here, do I? So I could just do PC like this. Whoops. Okay. Okay, so what I wanted is to do something like this. I wanted to get the location. Here. Okay, so if we're stepping into, what we need to know is, after having executed one instruction, did the location change? So let's call this pre-location. And post location. If star pre-location is not equal to star post location, so does that work? This should work. Oh, because I don't have const. I keep doing this mistake with this keyboard where I do Control S, but I accidentally hit Control A. Still not used to it. So, okay, is this okay? Const source location, this should be okay now. I just think the IntelliSense hasn't woken up yet. Oh, unless I need to make these const, yeah, because they're members. Okay, there we go. So if the location has changed and we're doing step into, it's time to break. Guess I'll call the same thing, break into debugger. Let me put that same code that I have right now for when I break, which is here. What just happened? So we want to break and we want to get out of this while loop. A little bit weird setting CPU cycles left equals 0 here though. Not a huge fan of that because it moves it away from where we play with MCPU cycles. So maybe I'll put this back just for now. We'll see how this looks. Mind you, I think I'm going to have to do it here as well. So, Alternatively, what I could do is that because maybe I just need it in this one function and I can keep everything kind of localized. So, okay, so let's say we do this. So what I do here, and then I say break into debugger. See, and if I guess I can't do break here because break, if I put a break here, is it going to break the loop? I suppose it would. No, it would break the step. This, yeah, I'll do return, I guess. Actually, what did I do in my other debugger? Oh yeah. Yeah, that's what I did. Okay, because I would set a bool. If anything sets it, then I would do this here, and I would break. On the fence. Excuse me. Some more water. I might go for that strategy, but for now I'm just going to see how far I can go with this. And the other thing I need this guy to do is it's going to break, but it needs to tell the DAP protocol, so through the session, it needs to send now how is that done in Hello Debugger? There we go. So StepIn, and then it says stopped event. This sends a stopped event to the client. On event paused. Oh yeah. Oh, I see what he did. I'm going to go with this instead. Oh wait, I have on event here. I already have this code. Breakpoint hit. Okay, so I already started this. Okay, so we'll do that. I don't know what to call it. I guess I'll call it pause because that is what I'm setting. Yeah, it's stepped. Oh, okay. That's the reason. I see. Stepped. Okay. Fair enough. So on event, let's copy this here. Okay, so that's stepped. So here it's not clear that that's why I'm breaking into the debugger actually. So I need to do this, and then I guess, right. So when did I send? Check for breakpoints. Oh, I was doing it here. So maybe what I'll do, I think it'll be more clear if I do this. Do that here, and then here we send stepped. So it's all in the same place. So this will send the event saying, okay, I've stepped, and then it's going to ask us for the next location. So let's see if this builds. Oh yeah. Okay, so let's just see if it works. Hit a 5. Oh yeah, waiting for an attach. Okay, so there's the initialize. You know what? I will put a breakpoint when we get the StepIn request. Okay, so I already have that there. Oh, I didn't say that we want to StepIn. Yeah, that's not going to help. just going to be lazy and make this atomic as well. And I'll deal with the right way to do this later. Okay. So if I go back to StepIn request, okay, so now, whoops, put a breakpoint there, and we'll say a breakpoint here. Okay. Let's see if this works. Hit F5 in VS Code. Go attach to Vectrexy here. Initialize. Okay, remove that. What's this? That's the stack trace request. Scope request. So now we should be at main, and sure enough we are. So what we're going to do is we're going to do this step into that's F11. F11. No. Oh, here we go. So I just got the StepIn request here. So we set that, we send a response. Strange, but oh, I need to keep running, right? Because I'm paused. Okay, I'm gonna hack this a little bit. Really what I should do here is make functions to set these. Let's go again. Sorry for all the jumping around, but that's what it is when you try to develop something that has to communicate this way in two different projects. Initialize. Some stuff there. So now we should be at our place here. We'll do step into, click here. So now we're going to say step into, we're no longer paused. Now we get into the step into. Now I'm going to grab my post location and we're going to compare it against the pre-location. So let's clear up some stuff here. Pre-location, post location. So as expected, they are the same in terms of like equality. They're not the same pointer, which is what I should fix. But you see it's the same source and same line number. Line 34, and that makes sense because there's actually two instructions at main that it has to execute. Right, as we saw, this is main. First instruction, second instruction. The third instruction, though, should be a brand new line, line 35, not line 34. So this is going to do nothing. And now here we are in the next one, and we still have line 34. Oh no, here. There we go, line 35. Now we should say break into debugger, and we should send a stepped event. Then it's going to ask for the thread ID. It's going to ask for the scope. And if we go back, and here we are. We stepped into recurse. All right, so let's see if this works, because this is great. Let's take off all these breakpoints and let's just see what happens. If I do F11, I'm inside recurse. F11 here. Wow, I've even stepped into my template function. Stepped into here. Oh my goodness, it's actually working. Oh shit, that's so cool. Of course, I'm recursing a lot here because I think I have a count of 10. Oh, 5. Okay, there we go. So now I came out of there. Now we're doing set beam intensity and exception thrown. Okay, so this is in Vectrexy. Okay. I think I know what happened here. I think I just hit the first line for which I don't have a source mapping. Yeah, let me see here. I don't have a post location. Yeah, I should probably check that they're valid. That would be smart. Okay, so I'll be more like I don't know. If pre-location and post-location are valid, so if they're valid and they're not equal, oh, actually I didn't want to run it. I just wanted to build it. You know what? And to make this now, to test this out a bit more quickly, we're going to modify our program to not recurse in Vectrexy here. I think it was this intensity here, set beam intensity. So let's go to main. Let's remove the recurse. And let's build. Okay, and let's hit F5. I got attach. Let's go back to main. We are F11 in here, set beam intensity, set scale. There we go. Cool. This is awesome. Okay, so select game is blocking because we are now here and we need to hit like a key to like, there we go. We need to tell it, you know, go ahead, go in. Let me do our clobber, select number of players, show, select game screen. Now, why were we here? Thought we stepped into that. Oh, I guess there's a last instruction. Oh, that's funny. There's probably one more instruction on our way out, which puts us here. Yeah, that's a bit of a shame. Okay, let's see. Now this is just data, so there's no code associated with that. Here we have some code to initialize an object. We're going to call from memory. There it is. We're going to do this reinterpret cast. And then we're going to probably initialize objects. We're going to go to its constructor. Very nice. It was interesting how we were on this line. Maybe that line is, I don't know. I'd have to look more deeply. Okay, so now we're calling min and max. Min, max. And we have a loop here. So yeah, I can't check the values yet. Hey, this is pretty awesome. And there we go. Okay, so now I can't really do much. If I continue here, it's not going to continue because I haven't implemented that yet. But we got StepIn 2 working. That's pretty cool. So some thoughts I'm having here are, there's some things I'm not a huge fan of so far, like this whole idea of the double threads. Not a fan of that. And all these atomics. Trying to think what I want. Because certain of these we can assume that we are stopped, like paused, and that means that it's okay for me to modify. But there will be certain things like when you hit pause, yeah, I'll think a little bit about that. It's not too complicated in my case because I really just have one thread running the engine and this other thread for DAP. So it should be pretty simple, but I don't really want to have mutexes all over the place, so I just sort of have to be careful there. Okay, so let's say we've got that. I think what would be really useful, I could either do, I think I'm going to wait for next, which is step over and step out, and I'm going to do instead I'm thinking what I should do is I should do like breakpoints and continue, F5 and continue and pause, and being able to set breakpoints anywhere. Because then I could pretty much do everything with that. Let me see. Is this a good time to commit this change? Probably. Okay, so DAP debugger implement StepIn. So let's do pause and continue because those should be relatively straightforward now. I think they call it stop, right? Continue request. Okay, pause request. It's actually called pause. Actually, I don't have to assert. What happens if you press... Can you press pause if you're not paused? I don't know. Assert that we're not paused. And then... So actually, one thing here is for this part to work, we need to step until we have a valid instruction. So actually, let me think here. Step until I don't know what to call it. Technically it's pausing. So maybe step always is not good. Maybe this should just be running. So basically what I mean by pausing is we want to break as soon as our pre-location, or I guess our post-location. Actually, we want to do it before we execute, don't we? Do we want to execute? I guess we could execute one more instruction. And if the current one is valid, if post-location is valid, break into debugger on event. Now we're going to add paused. So pause on the next valid source location. Okay, so in that case, my run state thing here for paused, it's not like this. So we're not paused, we're not going to do this. Instead, what we're going to do is, we're going to say run state should be, in fact, we could actually assert that the run state should be running, right? I don't know. Maybe not. Pausing. Let's do that. Let's see if this works. Oh, and I actually did not implement the pause event. Wait, why would I put run state step always? That doesn't even make sense. Oh, okay, because that's going to be what we would resume to? That's kind of strange. Wait a minute. Yeah, this doesn't make any sense. Okay, so you know what I'm going to do? I'm just going to go remove that attach thing for now. I don't really need to attach at this moment. I'm just going to see if it works. And if it doesn't, we'll debug it. Hit F5. Oh, actually I did pause, but I didn't do continue, so I can't actually make this work. Yeah, okay. So, you know what? I will debug this, because I realize if I don't attach, I'm not going to catch assertions and stuff like that. So if we have paused, we need continue. So we need the continue request. So in that case, we should be paused. And we want to go to running. I think that's it for that guy. Oh, and we don't want to be paused. That's true. Yeah, I think I'm hitting some of these assertions here. We'll see. F5, attach. RST parsing. Okay, so let's try, okay, before I do continue, let's put breakpoints in pause request and in continue request. So let's do continue. Okay, so we hit our breakpoint. So we should be paused. Yep. We go to running, we're no longer paused. So now you see we're running. If I come back in here and I hit pause, now we hit our breakpoint. Now we say pausing. So pausing should mean that we're going to pause on the very next instruction that has a valid location. So if I hit F5 here, see post location is currently 0 because we're on some instruction that doesn't have. So at some point, hopefully, we will hit, no? Oh yeah, of all the places I'm in, oh, there we go. Break into debugger. F5. And now, there we are. See, we were in show select game screen. This function, select game, it's a BIOS routine. Unless I support breaking into disassembly, which currently I don't, the whole time that that's being displayed, we can't actually pause into it. And as soon as it's over, because there's a timeout, we pause on the instruction right after. So that looks like it's working. And here F11 should bring us inside it. If I do F5 to continue, we should continue now. Looking good. Now this is going slowly because it's a debug build, so don't worry about that. Let's see now, if I take off my breakpoints, whoops. And I say pause. Here we are, we're in update audio. Continue, 6 to pause. Or somewhere else. Now we're in this loop here. Wow, often we end in update audio. That's interesting. What I'm doing right now is I'm doing continue pause, because I just want to see where we end up. I guess we're often in those two main functions. Update, right on update. Oh, because wait recal is a long function, so the chances are I'm going to be in there. And I guess draw as well. Print string is also a long running function. Awesome. This is so amazing. I can't believe this is working. And then we do stop. Wow, this is pretty cool. So let's see. So with these changes, we've now implemented implement, continue, and pause. Most of this code is going to disappear, all these commented out code. In fact, I should just remove it. Don't really care about CPU cycles total. Yeah, I suppose that could be interesting here. If something goes wrong, I mean. Commit the little cleanup. So I'm just thinking, what's next? So really what's next is step in and step out. But that is related to call stack tracking, which is the stuff that we implemented before getting into the DAP stuff in my other debugger. So we're going to need that. And I'm thinking maybe before I do that, it's all kind of related, but I need to show the call stack. So I integrate the call stack, we build it, and then when we break, we have to display the call stack in the call stack view. So that should be the next thing. And then after that, we can do step in, step out because it's related to the call stack. Now, for the call stack to work, trying to think here, I won't be able to display. Okay, yeah, I'll have to display addresses for symbols I cannot resolve. Otherwise, I need to display function names. And right now, I'm not storing any function name symbols. So that's the next thing I need to do. So let me write this down. Where's my to do? Here it is. Okay, so this is done. I think I put it somewhere else, didn't I? Oh yeah, this is all the stuff I put for my idea of DAP debugging. There we were. So what I'm going to do is I'm going to make a section called DAP debugger in my to-do. Okay. So what did I say? Add symbols for function names. Integrate call, or I'll say, whoops. I keep doing this. Show call stack. So this means integrate call stack tracking code. Display call stack as function names when available, or just address, or address otherwise. So we show the call stack, then we implement step over step out. These are all related to the call stack, right? I'll put this here. Implement breakpoint. Okay, I'll just remove this. So step over, step out, breakpoint. We also need to do locals. So locals is the window here, or it's called variables. Display values in locals. I'm not really sure yet how I'm going to handle that. I'm going to have to look at the stabs information to see what I can. This is like related to symbols and figuring out which symbols are available. That's going to be pretty complicated actually. I need to look at like mapping of registers or memory locations really, and if the current instruction does something like, yeah, that's a bit more involved. I'm gonna have to like analyze the current instruction and before we execute it actually, I suppose, and see which memory locations it deals with. Or maybe I could do a little bit like what I did for my debugger, and like when we execute an instruction based on the memory locations that were modified, then I can say, do I know symbols mapped to these addresses? And if so, display those. That's a possibility. But ideally what I would want to do is figure out which local variables are currently available and always display those. So yeah, there's some work there. Maybe display values of memory locations that were modified after executing instruction. Okay, but I think variables will come later. I think watch would be interesting. So there's watch, and of course there's different kinds of watches, right? There's expressions, conditionals, conditional breakpoints. So there'll be like normal breakpoints, and then there'll be like conditional breakpoints, which I'll definitely not do soon. Variables. So yeah, lots to do. I think that's a good start. So yeah, so next time we'll start working on this, adding the call stack tracking, symbols for function names, integrate call stack tracking code, display call stack as function. So if we can get this working, what it means is that when we hit F5 here, see, like here we are at main. Right now you look at here, it just says frame 0 main.cpp line 34. I mean, at least it shows the line number. That's good. I think that's because that's what I send. Yeah, but I'm not sending anything more than frame 0, right? Yeah, you see here. I'm setting the line location, the column, but for the name of the frame, what I need to do is, it's in here that I have to create a stack trace. So I'm only pushing one frame, but I need to push a frame per stack. It's not too hard actually, now that I think about it. Oh, and it's cool because it actually already has this concept of the file that it's mapped to. And this, the name that I put here, I guess I suppose yeah, this will be the function name. Yeah, okay, that's right. That'll be the function name. And if I don't have a function name, I'll put an address. Exactly. All right, so cool. So definitely some fun stuff to work on. Really happy that this is working. It's amazing. I mean, I'm actually stepping through this C++ code, constructors and all. Able to hit F5, able to break with F6. Once we get inside here. So cool. Yeah, really, really awesome. Very happy with this. Okay, so I think I'm going to stop here because it's 11. So I will be back in a couple days on Thursday. So if you want to see the continuation, join me on Thursday. And yeah, so thanks a lot for watching, and I'll see you next time.